Hello everyone, welcome to the Computer Vision and Machine Learning Lab using OpenCV. Myself, Dr. J. Sivaramakrishna, Professor in Department of CSM, Narayan Engineering College, Gudur. Today we will discuss the second lab experiment. So that is apply edge detection. The techniques include Sobel, Canny, also thresholding techniques on grayscale and color images. So this is the objective of the image is you are going to perform edge detection using Sobel as well as the Canny techniques. Before we deep dive into the lab experiment, we will quickly look at the Sobel edge detection. What is the Sobel edge detection? So it is a gradient based edge detection technique. So which is to find edges by measuring the rapid changes in the intensity of the images. That is rapid changes in the intensity of the images in the X and Y direction. And it combines both differentiation as well as smoothing techniques. Differentiation for gradient calculation, smoothing for noise reduction. So why we need to go with the Sobel? The advantages of this Sobel technique is the algorithm wise it is a bit faster and which highlights the regions with high spatial frequency and provides both magnitude as well as direction of edges. So which is very important. If we look at the edge detection, you can find the magnitude as well as the direction of the edges. And the other edge detection which we are going to use in this experiment is Canny edge detection. So it is a multi-stage edge detection algorithm widely used because it produces a clean, thin, accurate edges. So you already know if you have an image, there will be standard edges. Now the idea is you want to extract those edges from the images. So even it is a noisy image, the idea is to extract the accurate images. That we can go with Canny edge detection. So when compared to Sobel, Canny edge detection is having some advantages like which will detect real edges with better localization, also reduce noise in the images and across the edges, avoids detecting the false edges. So in Sobel there is a possibility of getting some false edges, and Canny this will totally avoid this Canny edge detection. Now we will move on to the lab experiment. So let us go to the folder which we have created the experiment. So first we will open the command prompt using the CMD. Now we will open the Jupyter notebook. So you know the command, that is Python space -m notebook. This will initiate the Jupyter notebook from the dedicated folder. So it is trying to open. It will open through the browser. Okay. Now let me open the experiment which we have created. As usual, we begin with importing the required packages. Here the packages includes OpenCV, that is CV2, import CV2. The other package we use here is the NumPy, which we import as NP. NP is the alias. Now first let us read the image. So we know the image can be it should be stored in the folder where you are working the or designing the experiment, lab experiment. So let us create a variable called image, and using OpenCV, the command cv2.imread, we will read the image. Here you need to specify the exact path or location of the image where we have stored the image. So here this is your image 1. Now this time we also create, suppose if there is no image in the specified directory or the path, so this will prompt that image not found, please check the file path for the appropriate image. So let us run this first. So we are done with importing the required packages, that is OpenCV and NumPy, and let us run the image path and reading the image. So we are successfully done. So if there is no image does not exist in the specified folder, that will say the command, that is image not found, please check the file path. Now so let us resize the image. So this we have seen in the first lab, that is using the command cv2.resize. cv2.resize of image. Image is the variable where you have stored the actual image. So let us resize it to the convenient size. Here I am choosing 400, 400, that is height and width. So let us resize it. Done. Now since this is a color image, I would like to convert to the grayscale image. So using the command cv2.cvt color. cv2.cvt color. Image is the original placeholder where you have stored the actual image. And use the command, that is cv2.color bgr to gray. So bgr is the channel format which we use in OpenCV, right? So that we want to convert to the grayscale image. So this is stored in the variable, that is gray. Gray is the variable where you can store the grayscale image. So we have successfully converted the color image to grayscale image. Now let us apply the first edge detection, that is Sobel edge detection. So this will be applied with the kernel size. So to apply the Sobel edge detection, the required parameters include kernel size, and since it is x direction you want to apply, it is 1, and you also want to apply in the y direction. So accordingly you need to set 1, 0, kernel size we are setting it as 3, and in the y direction also it is kernel size is set as 3. Now combine for both x and y, Sobel x and Sobel y, so that will give the actual Sobel edge detected image. So let us run this. We are done. It's very speed in the execution. Similarly, the obtained image is stored in Sobel combined. This will give you the Sobel edge detected image. The other one is Canny edge detection. So use this Canny. So where we use the command cv2.canny gray, 100, 200. So these are the parameters we need to define to perform the Canny edge detection. Right? We have done the two operations. Now the thresholding. So we have seen the thresholding. You need to set a value, cutoff value. From there you want to run this threshold. Okay, so we know this underscore where the first outcome of this operation is having no significance, that you can ignore, whereas the second outcome of this method threshold, that we are going to save in the variable, that is binary threshold. So whatever you obtain the outcome, that is the first outcome, that is having no significance. So cv2.thresholding. Here we are setting the threshold values as 127 to 255. Use the command cv2.thresBinary. So let us run this. Run successfully. Now perform adaptive thresholding. Adaptive thresholding. So here we use the command cv2.adaptive threshold. So over the gray, comma 255, use the commands like cv2.adaptive thresh mean, cv2.thresh binary. So with these commands you can perform the adaptive thresholding. The next command is going to be the thresholding on a single color channel. So we know BGR or RGB, it is having 3 channels. Now we want to focus only on one channel. So let us take that single color channel as blue. So blue channel gives you that image. So it is nothing but extracting the elements in the blue channel. Extracting the elements in the blue channel. So blue threshold you are performing nothing but single thresholding. So use the command cv2.threshold. So this is the blue channel image. The image is purely on the image whatever we are obtaining, it is coming through the blue channel only. There you are going to perform the threshold. Blue channel is the input. Thresholding values are 127 to 255. The same command, that is threshold binary. Let us run this again. In this case, the first outcome of this operation have no significance. The second outcome which is obtained in this method as a result, that we are going to store or save in the variable blue thresh. Let us run this. We are done successfully. Okay, now we can see all the images of the operations. That is, we have done Sobel, we have the original image, we have done that, we have converted that color image to grayscale, we perform Sobel edge detection, Canny edge detection, binary thresholding we have done, adaptive thresholding we have done, and thresholding over the single blue channel also done. So accordingly use the command, that is cv2.imshow. So we know these are the placeholders where the results were stored, image, gray, right? So let us run this completely. You can also see the edge detection across the x direction and across the y direction, that is Sobel x, Sobel y, and the combined, Sobel combined, and you can see the Canny edge detection, that is in the variable Canny, binary thresholding, adaptive thresholding outcome, and blue thresholding outcome. Let us run this and see the outcome. We will see a bunch of images coming out from here. See, it is taking time to run this cell because it is trying to display all sort of images, all the images that we obtained in this experiment. Of all these images, see, these are the outcomes of the image. Here you can see the original image, which is a colored one, and this is the grayscale image. Now here you can see the edge detection in the y direction, that is Sobel y, and you can see Sobel x, this is Sobel x, that is edge detection in the x direction, and this is the combined edge detection using the Sobel algorithm. Also we can see Canny edge detection. This is your Canny edge detection, and this is your binary threshold that will give you 0, 1 only, and this is your adaptive threshold where you can see you can set the threshold or the cutoff value for thresholding, and this is your single channel thresholding, so which is your blue channel thresholding, of course. So these are the outcomes or outputs of all these experiments. Thank you.